Hello dear students, welcome back to Physics with Jagan sir daily classes, and today we are going to discuss third topic in the vectors. Topic name is product of two vectors. Product of two vectors. And here first point is scalar product of two vectors. Scalar product of two vectors. See, when two vector quantities multiplying and giving a scalar quantity as resultant is known as scalar product or dot product also. Scalar product or dot product. For example, force is the vector and displacement is the vector. It gives work. Work is the scalar. So this is scalar and these two are vectors. Okay, then next point is, see here, let us see some special cases in scalar product. Special cases. Number one, if theta is equals to 0 degrees, if theta is 0 degrees, then A dot B is equals to AB. And here I forgot to tell you one point. Therefore, scalar product represents as A dot B is equals to AB cos theta. A dot B is equals to AB cos theta. Here, how can we write this one? Because this block is present. Suppose force is acting like this by making an angle theta, and this is displacement. Now the force F cos theta component helps my object to displace. Therefore, work done is equals to F cos theta into S. This one we can write as F dot S. Similarly, for product of two vectors, we can write A dot B is equals to AB cos theta. Okay. Then here this is maximum value. Number two, if theta is 180 degrees, then A dot B is equals to minus AB. This is negative maximum value. And third, if theta is equals to 90 degrees, then A dot B is equals to AB cos 90, which is equals to 0. This is minimum value. Number 4, if theta is acute angle, then A dot B is positive, because cos theta value remains positive from 0 to 90 degrees. Now, if theta is obtuse angle, A dot B is negative, because cos theta value remains negative from 90 degrees to 180 degrees. These are the special cases for the dot product. Now next concept, dot product of dot product of unit vectors. It is important to represent. Suppose it is I, j, k, that is x axis, y axis, z axis, and this is I, we represent with, this is represent with j, this is we represent with the k. Now here I dot I is equals to magnitude of unit vector is 1 1 cos I dot I means one I is lying on other I, that is one x axis vector is a vector which is representing on the x axis is parallel or which is held on the other vector, so the angle between these two is 0 degrees, so this becomes 1 1 1, therefore I dot I is equals to 1. Similarly j dot j is equals to 1, k dot k is equals to 1. Okay, now next point, let us see for I dot j, that is magnitude is 1 1 cos 90 degrees, that means if it is I, j, angle between them is 90 degrees, therefore it leads to gives us 0. That means similarly j dot k is also 0, similarly k dot I is also equals to 0. Clear? Then next one is let us see some examples over this concept. Find the value of m so that the vector 3i minus 2j plus k may be perpendicular to the vector 2i plus 6j plus mk. Here a dot b is equals to, let us by using ab cos perpendicular they mentioned, so this becomes 90 degrees. Now a dot b is equals to 0, that is 3i minus 2j plus k dot 2i plus 6j plus mk is equals to 0, and I dot I gives 1, I dot j gives 0, so this one is multiplied with this one only. So and similarly this one will be multiplied with this one, and this one will be multiplied with this one, so this becomes 6 minus 12 plus m is equals to 0, therefore m is equals to 6. Then next point, here what is the angle between the following pair of vectors? A is equals to I plus j plus k and b is equals to minus 2i minus 2j minus 2k. Then by using a dot b is equals to a b cos theta, then cos theta is equals to a dot b magnitude of a magnitude of b, then cos theta is equals to I j k minus 2i minus 2j minus 2k by magnitude of 1 square 1 square 1 square minus 2 square minus 2 square minus 2 square. This is I multiply with I only, j multiply with j only, k multiply with k only, so minus 2 minus 2 minus 2 root 3, this is 12, right? Then this is minus 6 by root 36 minus 1. Therefore, theta is equals to 180 degrees. This is what is about scalar product. Now, vector product is vector product. The multiplication of two vectors gives a vector as a resultant is known as vector product. And here this representation is, see, while we were discussing scalar product, we would never consider about the direction, and because we are getting a scalar as the resultant, but when we consider vector product, we are getting a vector as the resultant. That means we need to represent its direction along with the magnitude. So the representation is a cross b is equals to a b sine theta n vector, right? And this represents magnitude of a cross b, and this represents direction. And as we have seen in our previous class, the unit vector is helps us to find the direction, but it does not change us any magnitude of the quantity. Now, next point is cross product direction finding. See, by using our right hand curl rule, suppose if my palm is rotating from x-axis to y-axis, the thumb the thumb direction represents the resultant direction. That means I, j, k. That means if I cross from I to j, then this represents k. Similarly, if I cross from j to k, then this gives I. Similarly, k to I, this represents j. And simultaneously, this is j cross I is equals to minus k. Similarly, k cross j is equals to minus I. I cross k is equals to minus j. And this direction can be find by using right hand palm rule. The thing what I discussed just now is known as right hand palm rule. Next one, sorry, finding then next one, finding magnitude of two vectors product by using vector product. See here, the condition is let A is equals to AXI, AYJ, AZK, and B is equals to BXI, BYJ, BZK. Then here A cross B is equals to, we can use determination method, AX, AY, AZ, BX, BY, BZ. So I is equals to, I into in determination process, if I am considering for this one, I have to cross multiply these two. So ay bz minus az by. Now taking this one, so while taking second term, I have to keep negative sign, j of, then these two and these two, ax bz minus bx az. Similarly, last k. So this time these two cross product, that is ax by ay bx. This is a cross b, procedure of finding cross product. Now next one is important note. Finding area of parallelogram using cross product. Suppose this is the parallelogram, and here area is equals to base into height, and base is here a, and if it is b, this becomes b sin theta. So a b sin theta, and this automatically gives us a cross b. So area of parallelogram we can find by using cross product method or vector product method. And based on this concept, let us have a question. The question is, calculate the area of triangle determined by the two vectors a is equals to 3i plus 4j and b is equals to minus 3i plus 7j. Now here area of triangle formula is like this. Let us say it is a, it is b. Now this is b sin theta. So area of triangle is equals to half into base into height. So half into base is a, height h is equals to b sin theta, that is 1 by 2 a cross b. Now how to find a cross b? As I told you, by using determination method 3, 4, the given values 3, 4, but no jetter 0. Similarly minus 3, 7, 0. Now here as I told you, I, these two cross product 0, minus j, these two cross product 0, plus k, for the third term again I have to write plus. So these two cross product, that is 21 minus of minus plus 12, which is equals to 33 a cross b value. Then therefore area of triangle is equals to half into a cross b, which is equals to 33 by 2 units. This is about vector product. And if you have any doubts or if you need any material, you can message me in our YouTube channel, or you can follow me in our Telegram channel, Physics with Jagan sir. Have a great day. Take care. Bye bye.